Hello, I'm Li Hao. Welcome back to the Build Your Own Svelte series. In this video series, we've gone through 3 videos, starting with just how you can build your own Svelte, and we've talked about how we can take in more complex expressions, and in the last video, we even talked about how you can create reactive declarations in your own Svelte. Although in the last video, we've talked about this video, I'm going to do some refactoring, but that video was taken more than a year ago, and I realized that there's a lot of things that have changed over the years, especially at the time of recording. Svelte 5 is coming, and the last video was recorded with Svelte 3, so a lot of things has changed. Well, you can figure out how you can do some restructuring of your codes to make it more manageable, but in that video, I was promising that we're going to do that so that you can understand the Svelte codes better. But that was no longer the case because I believe in Svelte 5 we'll do a major refactoring, and what I was planning back then was no longer applicable and relevant right now. So in this video, I intend to just change the whole focus and to just make this whole series complete. We can't run away from building our own Svelte without doing, server-side Svelte. And that is what we are going to do exactly in this video. In this video, we're going to learn about how we can make, take the same code that we have been building up over the past 3 videos, but we're going to add a new options to our own Svelte compiler. We're going to turn it such that we have a flag called the target. You can take in either in CS client side or SSR. I'm gonna keep the value as the same as the current Svelte version, where basically it's either DOM for client side or SSR for the server side. And with this, we're gonna use if the flag is for server side, we're gonna turn our code differently so that it compiles to just a function that returns you a string. And you can take this function, put it on your server so that it runs, and whenever someone visits your site, you can run this function such that it returns you a string, and that will be your HTML string that you can return to your user, right? So that string can be dynamic. You can render your component dynamically so that it returns different contents for different users, and we're gonna see how we can turn the same code that you write on our same Svelte component from compiling it to JavaScript that runs on the client side to the JavaScript code that is a JavaScript function that can run on the server side. Right. So that is what we're gonna do in this video. So let's take our focus into the code that we have so far. So over here, this is our Svelte component. I'm not sure you're still remembering it. Of course, if you watch the past 3 videos right now, this should give you some recap of what we have done over the past. For new you who just started watching this, you may have no idea what we're talking about. But if you take a look at the timestamp, we have been time skipping for over the 1 year. Anyway, without further ado, this is the components that we have, and this app.js is the code that is being generated by our Svelte compiler. And also compiler code is here, index.js. Okay. If you are just new to this video, you have not watched the previous video, my suggestion is to watch them. It will be on my YouTube channel, and I will have the link over here in the description box. And if you want to get this piece of code over here, what you can do is, let me pull up my Chrome. You can find them on GitHub, and in my GitHub repository, this is the full code that I have used in my video. You can check it out. And so you can clone the code and you can start from there as well. Okay, so let's get back to the code. Over here, this is how the Svelte compiler works. Just a recap. We parse our code. We read a code from the file, and then we parse it into a AST, which is abstract syntax tree, abstract representation of our code in a tree structure, and then we do some analysis to it, and then finally we generate the code, generate a JavaScript code out of the abstract syntax tree, out of the Svelte abstract syntax tree. Right? So if we're gonna compile our code to server side, what we're gonna do is we're gonna change this function. Okay, this function will have to turn our code into a server side code rather than just a JavaScript, client side JavaScript code. So this is just a very rough outline. You may have your well encapsulated it, but here what I'm going to do is I'm going to have a flag called compile target that we're going to have the value called SSR. And if compile target is equal to SSR, then we are going to generate SSR with the same AST and analysis. And if it's just for the client side, then we're gonna do our old generate function. Okay, so this compile target right now is hard coded to SSR, but if you want, you can take this, have this variable to be taken in from your command line options or other functions that you other parameters that you have. But in this case, we're just gonna demonstrate that you can have this and you can use this flag to switch between compile to server side or the client side. So this generate SSR is the function that we are going to implement. So let me just create that function first before we go deep to figure out how we're gonna implement this. Okay, so when you build a framework like Svelte, usually I will go the figure out what the code looks like before we actually go into the compiler and then write something, right? Because the end goal is we want to have a compiler that takes in the AST and then churns out the JavaScript code. But if we have no idea how the JavaScript code would look like, then how are we going to implement that generate SSR function, right? So we're going to figure out how the compiled JavaScript code for the server side should look like first. Okay, so here I'm gonna create just a temporary file called ssr.js, and I will switch it to the right, and on my left I'm gonna show you this Svelte component that we just showed you just now. So right now we're gonna turn this into something, right? And we're gonna turn it into a JavaScript function. So we're gonna call this function my component. So I'm gonna say maybe app component. And this function, we need all the variable, all the function that you've just written over here. So all this, we're gonna copy it over, right? But the reactive, this has no special meaning or does not even need to do special things in the server side, right? Because your user will not interact with the server-side code. The server-side function, what it does is that it will take it, it will be called when there's a user request for it, and then it should return the HTML string directly and then send to the browser, right? And then the user will interact with the code, with your application in the browser, which should interact with the client-side code instead of the server-side code. So we can keep this, but we don't have to do extra logic with our reactive declarations or statements. But what we need to do here, of course, is we need to declare these variables if they are not declared, because or else we can't access them. We can't define, we can't assign a variable to it because we haven't declared this variable, right? So we need to declare, say, quadruple, double, and bar. Right? We can keep this. These are just this have no extra meaning in JavaScript than like in Svelte, because these are just a label statement. Just tell JavaScript that this statement has this label, and that's it. Right? Usually you don't do things with the label statement, except that maybe in a for loop, while loop, you might want to break to a specific labeled statement. But in this case, we can keep it, or we can just we can do something about it, like for example remove it, but it doesn't really matter. Okay, so now this function, we have all the code in your script. it has to do next is it needs to return a string, right? So it needs to return a string. And how should the string look like? In my opinion, the string probably should look like this. Basically, it should contain everything that you have over here, right? This should be how the string should look like. Of course, for expressions like this, I would think that it should turn it into a template string such that these are the literals that is inside the template literal string, right? For example, these expressions over here, these expressions over here, this over here as well. And for on clicks, it doesn't really matter. I mean, like the HTML that you returned, this function doesn't even probably exist in the server, but it's definitely not the same function that you have in your JavaScript. So I would when you send it over, you can't send the function over. Even if you try to put all this thing inside here, it doesn't really make sense anymore, because counter, the counter variable that you're referring to here, what does it refers to, right? So the on click, we're just gonna throw them away, because once the client side, when they execute this, they will define a new set of variables, and then they will assign like click event listeners and stuff like that, right? Those are totally two different places that you run the code, and two different instances, right? So for all the on clicks on a server side, for all intents and purposes, we're gonna remove them. They are not useful at all, right? So eventually, this is how I would imagine our code would look like, right? It will return a template literal string, because so that it leaves us some places to have expressions, so you can use the value of the expressions inside our string. And so this is the full return string from our app component function. Here what I'm going to write is that I'm going to export default app component function, and that's it. And so how do we run this? Okay, so firstly, for the client side code, we have an index.html that we serve, that we open to take a look, and then this will give us will runs the app.js, which we built from our own Svelte compiler. And if we're gonna build this file, this SSR.js, then we also need a way to just run to show you, right? So to show you, I'm gonna create maybe a file called server.js that will import this SSR file. So I'm gonna say app component from SSR, and I'm gonna console log out whatever it's written from this function. And I'm gonna run it and show it to you. All right, so I'm gonna say node server.js. Hold on. I need to extensions. Clear this and run this again. And this is what's being returned or prints out by the function. And if we take one more extra step, we can actually create a server and then return the return value, the string, as the response from the server. So this is like a HTML response, and so that when the browser will sees it, it will take this string and then render and display your application in the browser. Okay, so let me quickly create a HTTP server and to return that, and we can quickly take a look how does that feels like. All right, so here I'm going to create a bare minimum server in our Node.js. So it's gonna import from the node create server, and create server takes in a request and response. I'm just ignore whatever request it is, but for the response, I'm gonna write all there is from here to return them, and then that's all. I'm gonna end the connection, and this gives us a server. And for our server, we're gonna listen to port say 8000. Okay, and so let's start our server, and it hangs there because our server is running, just because we didn't print anything, but it is running. So let me quickly create another terminal, And here I'm gonna call for the HTTP localhost 1000. Hold on, localhost, and sure enough, this our server runs and then returns whatever it's this function returns us. Okay. Yeah, you can't see it running, but let me just console log and then you can see that it is running. It is indeed running over here. Receive a response. Let me kill this, start again. And sure enough, we run this, return the same thing from our curl, and then this prints out the logs. Okay, just prove that this is indeed running. And if you have a if you open a browser and you visit localhost 8000, sure enough, this returns your browser will make a request and then receive the exact response that we just saw just now. And then because that is a HTML response, the browser recognizes it and then parse it and render or display the contents of the HTML represented by the HTML into the screen. That's why you can see all this in the screen. Okay, of course, you can't interact with it because we haven't run any JavaScript in our HTML, but you can see the content is there, except that we have a NaN. That is because in our reactive declaration, we actually ordered it wrongly. We should reorder the reactive declaration such that if we run this again, and this runs in the right order, and such that this will return or printed render HTML that is correct, right? So that is something that we'll need to handle later on in our app component. So we have seen that basically this component that you just write over here, this can turns into this function. Let me close this. This turns into this function that returns a string, and then this string this function will export it out and can be plugged in or used in any server-side code that you have, namely just to return this HTML response. And if you have that server, have it running, then you visit that server, then your browser will take that HTML and then parses it and then generates or display this contents based on the HTML. And our job today in this video is to create this function. So how do we do that? Let's quickly go back to our index.js and we are going to implement our generate SSR function. Okay, there's a lot of things that we can actually copy and paste from the previous generate function that we do for the for the client side code. Namely, we can use some traverse method so that we can step through all the HTML nodes, as well as we are going to I think the analysis part we can ignore it, but for a situation where we are not here, but the part where we use reactive declaration and we try to sort it out, I think this we will definitely need them. We'll need this part. Let's see, update generate. Yeah, we will definitely need this code, right? And then lastly, of course, the function that we return, we have to figure out. I think we don't really need much because the server-side code that we generate looks a bit different. So we're gonna we will implement them ourselves. So let me quickly copy some of this code over here. Okay. Let me just copy everything and then we remove things that we don't need. So I'm gonna copy and I'm gonna paste it over here. And of course, immediately I'm gonna delete all variables I think we need, because these are the variables that is being defined or from our reactive declarations. We're gonna keep them over here. This one we don't need. This generate code from our AST script, yes, we do need them. Because this will generate take our code that we have from here and then generate them out. So we do need them. Oh, hold on. Take this code over here and then generate them. Let me close this. Take this code over here and generate code, paste them in over here. So we do need them. And then for, hold on, let me take a look. Updates, we don't need updates. For reactive declarations, yes, we do need them. Gonna put it over here like this. Okay. And then for the life cycle, no, we don't need any life cycles. But over here in the end, we need something to return the string. So let me just put an empty string for now. And let's see, reactive declarations over here. Okay, so this is to sort the reactive declarations, and here we just need to take this thing. Okay, we just need to generate the code out of it. We don't need extra logics to updates or figuring out what needs to yeah, the update logic back, because those are runs on the client side. So remove those. And then of course we need to also add the variables in so that we can declare them at the top like this. Okay. So this is kept, this is done, this is done. And then for going through the nodes, hold on, let me see. Yeah, this is going through nodes and figuring out how to create the node. We are going to remove quite a few of them. Let me collapse this first. HTML traverse. Okay. This part. Okay, this part is to figuring out whether. So you may be confused if you have no idea what I'm talking about, all these different pieces of code, if you have not watched my first video, right? So if you watch my first video in this series about build your own Svelte, you're probably very familiar with all the code that we have seen over here. Okay, so this code, what it does is that it walks through the script again and then try to instruments the code, replace instruments the code a bit such that when you run or execute those codes, it will tell Svelte that something has changed and then forces it to re-update the variable, the expressions of these variables that are being used in a template. But for server side, we don't need them. So what I'm going to do is poof, delete them. Okay, bye bye. And so for the code, we have variables create, update, destroy. Actually, all create, update, destroy. These are life cycles for the elements. And because we don't need them, we are only return the string. We don't really need them. Okay, so I'm gonna remove them as well. And for traverse, right now, where the places we use for create, then remove them as well. And for attributes, okay, keep them. Children, we need to keep them. Yeah, create and destroy. Bye bye. For text, we don't need variable. This we don't really need this anymore. So bye. We will have to figure out something else in return. For attributes, this is for event listeners, so we don't need them, and so we're gonna remove. Okay. And for expressions, again, this we don't really need variables for the text element because we are not creating these DOM nodes, DOM elements on the server. So we're gonna remove them, remove the create. This analysis part, nope, remove all of them. Okay, so which means we will have to implement something in return. This one is the expressions, we could keep them. So variables, yeah, we don't need new variables for our elements as well. So here we are, we left with nothing much. Traverse, okay, we don't even need parent. Okay, do we have access to parent? Okay, so for this one, we collapse this code for the generate. For the SSR, gonna remove this as well. We don't, there's no references of parents or whatsoever. Okay, so this, we have basically cleaned up our generate SSR function. We just leave with the structure that we need. Let me recap what we have so far. So we left with the basic structure of the generate SSR function, which is we're gonna traverse through a template and try to generate that string that we will eventually return. So this tool will do that job. And then for reactive declarations, we need to reorder it a bit because we probably should do this in the analysis step so that we don't have to reorder again, right? I mean, if you want to refactor, because previously we done it over here because we only have client-side code, but now it's run on this logic will need on both server-side and client-side, so we probably need to refactor a bit. But here we are resorting the reactive declarations, the statements, so that it runs in the correct dependency order. And then here is where we basically go through each of them and then push it through into an array such that we're gonna run them, we're gonna generate them down here later on. And then for the variables, we need to declare them because you can't assign to a variable without declaring them first, right? So here we collect the list of variables, and so here we declare them, and then we paste in all the codes that is in the script text, except the reactive declarations. And here is where the reactive declarations we are generating them. Okay. So let me save this. Let me try and run and see if we run into any problems first, right? So here in previous code, we write our files to app.js, and now we're gonna write it to ssr.js. Okay. Definitely will overwrite this code file over here, just so that we have something to reference of what we have talked so far. Let me rename this to say SSR template. Okay, so this is how we would want our code to look like. And if we try to run our code right now, let me close this. Okay, so node index.js, where we're gonna compile the code. Hold on. Errors, it's always like that. Let me think, let me figure out. Okay, cool. Here, okay, we don't need this, we don't need a variable name. Okay, so let me try run again, and that's it, right? It prints out some information, but what you actually want to look at is the ssr.js. So this is the code that we generated from our code that we just have just now. Let me format it nicely. So here you can see it declares all the variables, and then this part is basically what is in your script tag. Let me right, this part is exactly what you have here, and then this is where the reactive declarations is in a sorted order, and then this is where we are going to implement now, right? It returns the string, and we're going to return a template literal string. Okay, so now our job is almost, hold on, compared to our template, our job is almost done, except the main bulk of it is over here that we need to figure out. Okay, so let's move on. Let's see how we can do that. So to do that, we're gonna figure out how we can generate this template literal string. And to generate a template literal string, what we need here is to know actually how the template literal string AST looks like, right? We're gonna piece that. We're gonna create that node. We need to know how that template literal string nodes looks like. Why? That's because what we're gonna do, right, is that, sorry, I don't have anything to visualize, so I'm gonna just open back the code over here, and the final output that we wish to see. So we're gonna step through the abstract syntax tree, right? We're gonna go through the button element and then go to this element over here, and then the children as this one, and then we're gonna go through the next element, and then it's children, and then more children, and then more children, and stuff like that, right? But along the way, if you try to piece it out, some of the element, for example, this element, and then this one, and this part, they are all one string, right? But sometimes when you encounter this, these are expressions. So how does this looks like in a template literal AST? So I usually like to use this website, although maybe to some of you, maybe it's not that friendly, not really sure how it looks, how you use it, but it is very useful for you to basically write any type of code. So this is a code that I would write, that I have here, and I want to see how this is represented in a AST, right? So this is what I've told you so far. This is a template literal. Okay, so template literal has two things that is very important, which is one, let me zoom it up a bit. One is the expressions, and another one is the quasis. Quasis basically is template element, which is basically the string over here. Okay, these strings are the quasis. Okay, so this until here is that the first quasi, and then you have expressions, which is the first element of in the expressions array. Okay, so which means that if you have this thing, what it does is what you can see is that you probably will have 5 expressions, then which means you have 5 expression elements in expressions. But then you will have 6 elements in the quasi, because you have one in between, right? One in front of expression, one again in front of expression, one in front of expression, one more in front of expression, one more in front of expression, and the last one at the end of the string. So you have 6 quasi for 5 expressions, right? So it's the quasi is always one more than the expressions that you have. So to create this template literal node, this structure over here, well, basically what we need is, as we step through the Svelte abstract syntax tree, we're gonna collect the expressions and collect the quasi. And as we collect them, and after we finish the whole tree, we're gonna piece them together into a template literal node, and then we're gonna stuck that node into our final code. Okay. So to do that, let's go back to here, and in here in our code, we are going to have a variable called template that has the expressions and the quasis. Okay, and so we're gonna piece them together later on. Actually, an easier way usually I've seen so far is we create, instead of pushing to this, we create some helper functions to help us along the way, right? One function is called add string. Another one is add expression. So string is, we're gonna have this template dot quasis dot push string, and then template expressions dot push expression here. Okay, and then so now let's go to our traverse and let's see what we can do here. So for elements, first thing is we're gonna create the opening tag, right? Some opening tag over here. So we're gonna add string. So it looks like this with the node name. Hold on. Node.name. Right? Is it called node name? Let me see. It is called the, yep. Node.name. Hold on. And then we're gonna go through the attributes, so that maybe you might want to print out things for the attributes. And we are done. So here, after we're done with the attributes, we're gonna add string to close the opening tag. All right. So here we open it, but we haven't closed it, so that we can add attributes. And so we print out all the attributes, and I'm gonna close the opening tag. and then we're gonna print out all the children, and then as we end, we're gonna add string to have the closing tag, right? The closing tag over here. Put it over here like this. And so for text, it will be much simpler, right? For text, we're gonna just add string to see what's the text content. So the node, what is for the text? The content of the text is the node value. Okay, so we're gonna create node dot value over here, and that's it. For attribute, for now, we're gonna handle. We only have in this demo, we only have we only have the event listener. So we're gonna skip this attribute for now, but in future maybe you can add more things, right? So just to demonstrate, I'm gonna add string called a maybe x equals to y, something like this, so that you will see that later on, just to show you if all the elements that has the attribute called x equals to y. And then for expressions, what you need here is that after you get this expression string, actually no, we don't need to get expression string, just need this expression. This is where we are gonna put this into our expressions array, and that's it. That's what we have. And after we traverse everything, we're gonna create that template literal, right? Before we do that, we're gonna print out how it looks like our arrays of quasi expressions looks like. We're gonna console log this. I remember we have other console logs. Okay, results. So let me those first. Okay, so here we're gonna log out the templates which have the quasi and the expressions, and let's take a look at how they look like. Node index. Oops, hold on. Here we need to add code. I almost thought that template is a variable name, but it's actually called the template. So here, template expressions. Oh, with an S. Hold on. And that's it. So here we have, let's see, we have 1, 2, 3, 4, 5 expressions, which is correct. But hold on, we have a lot of quasis. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have almost like 20 quasis, right? So that doesn't make sense. That doesn't work as a template literal. And I can show you how it looks like if I take this and then turn it into a template literal string. It's incorrect, right? You should only have 6 template elements and 5 quasis. But let me just show you how it look like. So I'm gonna create the template literal equals to the node, and then so here I'm gonna say the type is template literal. Expressions is the code the template expressions, and then quasis is hold on. So quasis is the template element for each of the strings. So we're gonna map it to map the string value to a node called type template element, and then the value is basically raw and cooked, but I think they looks the same to me, so I'm gonna say raw as a string, cooked is a string. And now we have our template literal node. I'm gonna use it in here. And of course, this is an AST, cannot put it into a string like this. We will have to generate, turn it into a JavaScript string. So this is how it looks like. And then let's try and run. And let's take a look at our generated code. Where is? Hold on, where is Is it this one? No, my God. Something went wrong. Hold on. Oh, wait. Put it here. No, so we should have it here, right? Run it. And this is what? This is this is an empty string. Why? Okay, is it because the array, the length of the quasi and the templates does not match? Right? Maybe that's why. That's why I told you that when I print it out, it looks a bit wrong. Wait, where's my? Yep, my template. Oh wait, my template literal I created before the traverse function. Let me close this. Right, you don't need to see that. So template literal is here. I need to put it right before, right after we traverse everything, and here we have this template literal. And let's run code. And it has problems, right? It runs into error because we have way more quasis than the expressions that we have. Okay, this is wrong. So how should we handle this? Why does this happen? That's because we've been calling. If we try to print out, when we are calling add string and expressions, and you will know why that happened. Okay, let me show you quickly. If I print this out, I think I can print what string we are passing as well. You will see that we don't call add string and an expression. Add string, expression. It doesn't work. We didn't do it like that. We might call add string multiple times, and then only we add expressions once. Right? We call add string and then expressions, and then add multiple strings at one time and expressions. But as a template literal, you need one string, one expression, one string, and one expression, right? So that there's like 6 strings and 5 expressions, or 3 strings and 2 expressions. It should always interleave, right? So in our add string function, we need to handle that so that we don't push too many quasis into the array, right? So what we can do is that we can accumulate the let me collapse things that are not needed. I feel like this code is getting longer and longer. Okay, so what we can do is that in this this is a generate function. Let me look at the generate string. Okay, so here collapse unneeded stuff. Here, what we need to do in our add string and expression is that whenever add string, we just accumulate the string. We don't push into quasi first. Until we meet an expressions, then we know that all the strings that we accumulated so far should go into the quasi array, because that you have one only, and then we have one expressions, right? So what we need to do here is that we're gonna collect them, right? The string, template string. We start with an empty string, and so here we don't add it to the quasi array directly, but I'm gonna add it to our string first, right? And then when we have an expressions, then we know that okay, we want to need to push to one quasi first before push to the expression. So here, what we do is we're gonna copy this, push the template literal string in, and then the template literal string should be reset to empty string, and then we push the expressions, right? So now we have one quasi, one expression, one quasi, and one expressions, right? So we only push the quasi when we have an expressions. And of course, at the end of everything, after we traverse and after we end everything, we need to also have this if we haven't seen, so the last part after the expression, the last part of the string, we also need to push them into the string array, so that to the quasi array, so that those are added as well, right? If you don't do that, what you will end up seeing, let me show you. What you end up seeing is that you don't have the last part, right? You only have up until here, because the last part we need after you push an express, you only have you after the push the expression, you don't have that string, that last part. So you need to push that as well, and you only do that at the end of everything. After all the traverse, you do that. So here I'm gonna push whatever that's left over in the template string, so that you have one extra template string than the number of expressions that we have. And now if I run again, and let's take a look at our final code that we generate. Wow, we have this whole, we print out everything, right? We even have our attribute, right? Which we don't really need the attributes. But basically this looks cool. Let me just remove the attributes because we don't really need them. Move it over here. And so this is the final code that we generate from our Svelte SSR compiler. Let me format it nicely, and let's try to run this function in our server, right? So here, to start our server, we're gonna run node server.js, and our server is started. And then in this over here, we're gonna call curl, right? Curl, and it returns this string, right? Wow, nice. And if we try to visit it on a browser, and I've refreshed, okay? This is the generated code from the server, right? To prove you that this is a working code, let me quickly change our component. This to be double this times 3. Oh no, let's say bar equals to bar over here. Okay, and then so let me try to compile this code and start this server. And now this is bar equals 10. Okay, this indeed comes from our server that we just built. You see that it receives a response, and we have indeed created a Svelte compiler for SSR in this video. So in this video, we figured out how we can how the SSR component JavaScript code should look like when you compile a Svelte component for SSR. And then we've seen how we can write that compiler. Basically, we copy a lot of code that we have for clients when we try to build for the client-side JavaScript code for our Svelte components. And we've seen that how we can basically build out our template string so that our template string itself can be used to piece out the whole strings that we return from our function. And that's it in this video, right? So if you like this video, give me a thumbs up. If you have not subscribed to my channel, please remember to subscribe, because in the next video, and also the last video of this whole build your own Svelte series, is that we're going to see how we can combine the client side and the server side together so that it becomes a hydratable Svelte component, right? So see you in the next and last video for the series. Bye!